In this video, we'll be going over a number of islands. So given an n by n 2D binary grid, which represents a map of ones, which represent the land, and zeros, which represent water, return the number of islands. An island surrounded by water is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So in our first example, we're given this grid, and then we can find one island. This is the single island because it's connected once horizontally and vertically. In our second example, we're given this grid, and then the number of islands we can find is 3. The first island's here, and the second island, and then the third island. Let's go over the thought process. So for each of the cell at RC with a value of 1, we will need to increment the number of islands. Now we should note that an island is connected once vertically and horizontally. We will need to mark the current island as visited to prevent overcount. Now, how can we mark the current island? We can implement a recursive depth-first search approach to find the surrounding land that are connected to the current cell. Then we can mark the cells or mark the island by syncing the island. This means converting all of the ones to zeros. This will allow us to prevent us from overcounting. Now let's go over the pseudocode. So we're going to create a variable, islands. Then we're going to iterate through the rows and columns of the input grid, denoted as RC. Now if grid RC is equal to 1, this means we have found an island. We can increment islands. Now we want to sync the island to prevent overcount. So we're going to implement a recursive approach to sync the island. Then what parameters do we need? We need the current row, the current column, and also the input grid. Now what's the base case? If RC is out of bound or does not contain a 1, this means the current cell is invalid. We do not need to sync the cell. We can just return from the recursive column. Then in each of the recursive column, we want to sync the current cell. So I'm going to set grid RC to 0. Then we're going to iterate through the 4 directions, denoted as D. Because we have 4 directions, because we can go up, down, left, or right. Then we're going to calculate the new row and new column. So the new row is equal to R plus D0. And new column is equal to C plus D1. Then we can recursively traverse to that direction. Then we can return islands. After we have synced the island, we can move on to the next cell, and then we will continue to find islands, and then we'll return the resulting number of islands. Now let's go over the time and space complexity. For the time complexity, we get O of n, where n is the total number of cells. This is because we visit each cell at most twice. Once in our for loop, and another time in our recursive depth-first search. In our space complexity, we get O of d, where d is the depth of the largest island. This is our recursive call stack memory. Now let's go over the code. So we're going to create a variable, islands, to keep track of the total number of islands. Then we're going to iterate through the rows and columns of the input grid. Then if the current cell is equal to 1, we have found an island. Then we're going to increment islands. Then we're going to sync the island. We're going to implement a recursive depth-first search to sync the island. This will prevent us from overcounting. Then we can return islands. Now let's implement our recursive depth first search. The current row, the current column, and the input grid. Let's go over the base case. If r is less than 0, or r is greater than or equal to grid.length, or c is less than 0, or c is greater than or equal to grid r.length, this means the current cell is out of bound, or grid rc is not equal to 1. This means we cannot sync the island because it is already equal to 0. Then we can just return from the recursive call. Now we want to sync the current cell. Grid rc is equal to 0. Then we want to iterate through the 4 directions. Let's create our directions array. So we get -1, 0, which means going upward, and 1, 0, which is going downward. And then we have 0, -1, which is going leftward, and then we have 0, 1, which is going rightward. Then we want to recursively traverse in that direction. Let me know if any questions in the comment section below. Like and subscribe for more videos that will help you pass the technical interview.